Hey everyone, and welcome back to the channel. Today, we're re-talking about one of the most exciting endeavors in modern space exploration. Humanity's grand return to the moon. Over half a century has passed since we last left footprints on the lunar surface, but a new era is dawning. This isn't just about repeating history, it's about building a sustainable future beyond Earth, and the chariot for this incredible journey is a spacecraft named Orion. So, what exactly is Orion? Think of it as the next generation Apollo capsule, but supercharged with 21st century technology. Built by NASA with contributions from the European Space Agency, Orion is designed to take astronauts farther into space than ever before. Its primary mission is to serve as the exploration vehicle for the Artemis program, NASA's ambitious plan to establish a long-term human presence on and around the moon. This isn't just a flags and footprints mission. Artemis aims to set up a base camp on the lunar surface and a gateway station in lunar orbit. This will be a stepping stone, a training ground for our next giant leap, sending humans to Mars. Let's break down the Orion spacecraft itself. It's composed of two main parts. First, there's the crew module. This is where the astronauts will live and work. It's shaped like the classic Apollo capsule, but is significantly larger, capable of supporting a crew of 4 for up to 21 days. It's packed with state-of-the-art life support systems, advanced avionics, and a high-tech glass cockpit. The windows are bigger, offering breathtaking views, and the interior is designed for longer-duration missions, making it a much more habitable space than its predecessors. Safety is paramount, so it also features a launch abort system designed to pull the crew module away from the rocket in case of an emergency during liftoff. The second part is the European Service Module, or ESM. This is the powerhouse of the spacecraft. It provides everything the crew module needs to function in the harsh environment of deep space. Propulsion to maneuver, electricity from its 4 massive solar arrays, and it regulates temperature, water, and breathable air for the crew. Essentially, while the crew module is the astronaut's home, the service module is the engine room and life support hub that keeps everything running smoothly. It's a testament to international collaboration, showing what we can achieve when nations work together. Now, how does Orion get to the moon? It rides atop the most powerful rocket ever built, the Space Launch System, or SLS. This colossal rocket is the backbone of the Artemis missions. During launch, the SLS will propel Orion to an incredible speed, enough to break free from Earth's gravity and begin its multi-day journey to the moon. The sheer power of this launch is a spectacle in itself, a roaring announcement that humanity is pushing the boundaries once more. You might have heard about the Artemis I mission, which was a huge success. In late 2022, an uncrewed Orion spacecraft launched on the SLS traveled over 1 million miles, looped around the moon in a distant orbit, and returned safely to Earth. This was a critical test flight. It pushed the spacecraft to its limits, especially its heat shield, which had to withstand reentry temperatures of nearly 5,000 degrees Fahrenheit, about half as hot as the surface of the sun. The mission gathered invaluable data, proving that the hardware, the rocket, and the spacecraft are ready for the next phase. Putting people on board, the next mission on the docket is Artemis II. This time, there will be astronauts inside Orion. They won't land on the moon just yet, but they will fly a similar trajectory to Artemis I, looping around the far side of the moon and returning to Earth. This will be the first time in over 50 years that humans have traveled beyond low Earth orbit. It will be a 10-day mission to test all of Orion's life support systems and capabilities with a crew inside. The 4 astronauts selected for this historic flight will travel farther from Earth than any human has ever been, paving the way for the missions to come. And that brings us to Artemis III, the mission we're all waiting for. This is the one where we land. Using the Orion spacecraft and the SLS rocket to get to lunar orbit, 2 astronauts will then transfer to a separate landing vehicle, the Human Landing System, to descend to the lunar surface near the moon's south pole. This region is incredibly interesting to scientists because it is thought to contain water ice in permanently shadowed craters. Finding and utilizing this water could be a game changer. It could be used for drinking water, breathable air, and even rocket propellant, making a permanent lunar base much more feasible. The astronauts of Artemis III, including the first woman and the first person of color to walk on the moon, will spend about a week on the surface, conducting experiments, collecting samples and exploring this new, uncharted territory. After their surface mission, they'll launch back up to rendezvous with their colleagues in Orion, who will have been orbiting the Moon, and then all four will journey back home. But the Artemis program doesn't stop there. Subsequent missions, Artemis IV and beyond, will focus on building out the lunar infrastructure. This includes delivering components for the Gateway, an outpost orbiting the Moon that will act as a command center, science lab, and waypoint for missions to the surface and, eventually, to Mars. Orion will be the primary crew transport vehicle, a sort of deep space taxi ferrying astronauts between Earth and the Gateway. This long-term vision is what makes the Artemis program and the Orion spacecraft so significant. It's about sustainability. We're not just going to the Moon for a quick visit. We're learning to live and work in another world. The science we'll conduct will be revolutionary. We'll learn more about the formation of our solar system, the potential for resources beyond Earth, and how the human body adapts to long-duration spaceflight. The technologies developed for Artemis, from advanced life support to new propulsion systems, will have benefits right here on Earth, just as the Apollo program spurred innovations in computing, materials, science, and medicine. So, the next time you look up at the Moon, remember that we are on the cusp of returning. The Orion spacecraft is more than just a piece of hardware. It's a symbol of human curiosity, ingenuity, and our unyielding desire to explore the unknown. It represents the collective effort of thousands of engineers, scientists, and dreamers who are working to write the next chapter of human exploration. We are truly living in a remarkable time for space travel, and the journey is just beginning. Thanks so much for watching. If you're as excited about our return to the Moon as I am, make sure to hit that like button and subscribe for more deep dives into the future of space exploration. Let me know in the comments what part of the Artemis program you're most excited about. Until next time, keep looking up.